Hi there. Didn't see you there. What are you? Oh, doing some math here. I see. Cool. Oh, you want me to show you how to do it? Oh, wow. I'm flattered. I'm no Wes Workman, but I'll give it a try. I mean, this is circle geometry stuff, dealing with circles. Okay, I can take you through some of this stuff. Yeah, some terminology. So we're going to deal with circles here with chapter 10. So there's a whole bunch of different rules when I learned this anyways. So it's important to know if you're going to learn a rule, you need to know what some of the words in the rule actually mean. So we'll maybe start with that. I think that would be a good place to start. So some of this might be review. I think some of it might be new. So a chord, one thing that you need to know is that a chord is any line that connects 2 points on a circle. So a chord could be anywhere. This is a chord, this is a chord, this is a chord. This line here runs to the middle. It doesn't run to another point on the circle, so that's not a chord. Okay. A central angle is an angle formed from 2 spots on the outside, and it cuts into the middle of the circle. So this angle that's being formed in the middle, that's called a central angle. And an inscribed angle would be one that comes from 2 points and meets at another point on the line. Okay, so right here, that creates an inscribed angle. So really, anywhere else you could have an inscribed angle. That's an inscribed angle. Okay, and then an arc. An arc is just basically the meeting point, or how far away 2 points are on the outside. This could be an arc. You could say the arc from here to here. It's basically just hugging along the outside of a circle. Okay, so there's some terms. In 10.1, we're going to learn 2 basic rules with circles. Okay, so here they are. Again, you need to know what some of these words mean. So the inscribed angles subtended by the same arc are congruent. Okay, so subtended by the same arc just means they're coming from the same 2 points. Okay, so if I take a point here and a point here, and I make an angle here, right, I would get an inscribed angle here. It's coming to a different point. Now, if they're subtended by the same arc, that means you're taking the exact same 2 points and going somewhere else. Right? So it could be over here, it could be anywhere else on the circle. So what this first rule says is that the inscribed angles subtended by the same arc are congruent. So that means these 2 angles are always going to be the same. So if they're coming from the same 2 points over here or wherever else, they're always going to give you the same size angle. That's kind of a neat rule for circles. So those are inscribed angles. The second rule here is the central and inscribed angle rule. It says that the measure of the central angle is equal to twice the measure of the inscribed angle subtended by the same arc. So again, mouthful. It's important to jot these down and know them. But I'll just show it based on here. So here, if I take these 2 points, and this is the one arc that we're going to subtend, we're going to both come from that arc. Here's an inscribed angle. Here's a central angle. And this rule is saying that the central angle is going to be twice as big. And that's going to always be the case. Okay, so it's going to be twice as big, this angle compared to this angle. So if I took from here on this one, if this was, let's say, a 20-degree angle on both of these, because they're the same, if I took another angle and went to the middle, it would be, 40, exactly. So would be the central angle. It's always going to be double. So if we know the central angle, we also can go the other way and figure out the inscribed angle is going to be half. Okay, so 2 simple rules that you're going to be dealing with in 10.1. Okay, so we'll just jump through a couple examples here. What's the measure of angle ADB? So we've got this picture, I just blew it up here. So A to E to B. Just keep in mind when you're reading an angle, that you start at one, the middle part is where your angle is actually going to be. So A to E to B. It tells me that it's 35 degrees. What's the angle of ADB? Well, these are subtended by the same arc, right? There's that arc that's both of these angles. ADB is coming from the same one, so we know it's got to be 35 degrees. Okay? And then in B, what's the measure of ACB? Well, it's subtended by the same arc, but instead of going to a point on the side, it's going to the middle. So we know the middle is going to have to be double, so it's 70 degrees. Okay? So hopefully pretty straightforward, and I feel like a pro. Okay, again, it's just using the same rule. As long as we keep track of where the points are, right? If I take this example here, and I look at D and B, I've got an angle coming from D and B. This is the arc that it's subtending. Both of these angles are subtending this arc. So here's an inscribed angle, so that means coming from the same 2 points to the middle has to be double. So it has to be 110. Whereas if I'm coming from here, this is an inscribed angle, right? Coming from subtended by the same arc, an inscribed angle, this one's going to be a 55 degree. Okay, I find it easiest to just fill things out on the picture, so quickly just jot down your own circle even, and then just work your way through it. I find that's definitely the easiest way to go about that. Okay.